Good morning, all. Welcome back to session number 2. So basically, in session number 1, we discussed about wind energy. The introduction part and the classification, characteristics of wind, and how wind machines are classified, and different types of wind machine based on the axis classification and based on the type of rotor. All these things we already discussed in the session number 1. So now today we'll start session number 2, and in session number 2 we are going to discuss about the different types of wind machines. Those are nothing but horizontal axis wind turbine and vertical axis wind turbine. Then advantages and disadvantages of both horizontal as well as vertical axis wind turbine. So we'll try to cover these topics in today's session. So first one, so as we discussed in the session number 1, the second type classification basically depends on the type of axis. So based on that classification, we have two types. One is nothing but horizontal axis wind turbine. Second one is nothing but vertical axis wind turbine. So first we'll start with the first one, that is nothing but horizontal axis wind turbine. This is the schematic of horizontal axis wind turbine. So these are the different components like rotor and windmill head, tail vane, supporting structure, foundation. And this windmill head, it includes other components or devices like gearbox, controller, and accelerometer. These are the different devices it will include. So first we'll try to understand the importance of each component. Then we will discuss about the working of this horizontal axis wind turbine. So component wise, first we'll pick foundation. Okay. So if you take any wind turbine, right, basically the foundation gives the support to the tower. Okay. Because the wind turbine includes different parts, right, with which are having which we can say which weigh in tons. Okay. That's why that should be strong. Okay. And second component is nothing but tower. Okay. So the tower basically it is used to give support to the rotor hub as well as the nacelle region in the upper portion. Okay. And the material used for to make this is in most of the cases they will prefer concrete. Okay. And coming to third component, that is nothing but blades. Okay. So wind turbine blades. So basically these blades are in aerofoil shape. Okay. Compared to vertical axis wind turbine blades, those are D-shaped blades. So basically in horizontal axis wind turbine, we are using aerofoil shape blades. Okay. And these blades are mainly used to remove the kinetic energy of wind, and we can change it into the mechanical energy. And these types of blades are designed with different materials, different composites, like fiberglasses, reinforced polyesters. These are the different examples for the blade materials. Okay. And the number of blades, right? The number of minimum blades start with a single one blade to multiple blades. So nowadays in most of the horizontal axis wind turbine, they prefer 3 blades. So by using 3 different aerofoil blades, we can run the horizontal axis wind turbine. Okay, this is about blades, in rotor blades. Then next component is gearbox. Actually, the gearbox is installed here. So the basic inside the windmill head. Okay, and it is connected to the lower shaft, lower RPM shaft. Okay. So the basic importance of the gearbox is it will convert speed. Okay. So whatever we are getting the speed with the help of that wind with respect to lower wind shaft, that we can convert it into higher RPM. So that is the main importance of the gearbox. Okay. By using that gearbox, we can increase or can improve the speed. Okay. So next component is generator. So the generator and the rotor, can call it as sometimes it's turbine rotor, right? All these two components are coupled with a common shaft. Okay. So the importance of generator, basically the generator converts the available mechanical or converted mechanical energy into electrical energy. So this is the basic importance of the generator. Okay. So this is about, this is the basic information regarding the different components what we considered in the horizontal axis wind turbine. Okay. So now we'll discuss about working of horizontal axis wind turbine. Okay. So in working, especially once the wind blows, a wind turbine changes the kinetic energy from the motion of the wind into mechanical energy. This is the primary conversion. Okay. So how we are converting that into mechanical energy means by through a revolution of the rotor. With the help of the revolution of the rotor, we can convert that kinetic energy into the mechanical energy. Then after that, this converted energy that can be transferred through the shaft and the gear with the help of gear, right, towards the generator. And we know that the generator, the importance of generator is to convert the available or the converted mechanical energy into electrical energy. So this is the basic working principle of horizontal axis wind turbine. Okay. So along with that, so when you talk about the blades, right, blade tip and pressure difference we are creating with respect to this upper and lower head of the blade, so which will drive the rotor. Okay. So this is about the horizontal axis wind turbine. Okay. Similarly, we have one more type, second type, that is nothing but vertical axis wind turbine. Okay. So as name indicates here, the vertical axis, you can see this is the vertical shaft. Along with the shaft, the other accessories or components are mounted at the bottom of the shaft. So whereas in the previous slide, the shaft it's a horizontally. This is the shaft and it is placed horizontally. Whereas in this thing, you can see this is the shaft, it's placed vertically. And whatever the other components we are using like gearbox, nozzle reason, and rotor, accelerometer, all those things, right? These are mounted at the bottom side of the setup, wind turbine axis turbine setup. Okay. So component almost similar components. Okay. Here also you can expect similar components, but the major difference is the axis. So here it's in a vertical axis. So previously it was horizontal in first type. Then the major difference is blade shape. So in the horizontal axis wind turbine, we used or we consider the aerofoil shaped blades. Okay, but whereas here those blades are entirely different. The geometry of the blade is entirely different when you compare with the horizontal axis wind turbine. Okay, so these shape of these blades are similar to D, like the letter D. So alphabet D. Okay, so that's how, right, it looks like D. That's why the name tells, right, the shape of the blade is normally, technically we can't call it as a D shape, right? So for the convenience, for our convenience, we name like that. So D shape blade. Okay. So here also coming to working principle, right? Especially the vertical axis wind turbine, it is a type of a wind turbine and it is most frequently used for the residential purpose. So you can't use this kind of turbines for engineering applications side. Okay, these are restricted or limited to residential purpose to provide renewable energy sources to the home. Okay, this is the basic importance of this vertical axis wind turbine. Then especially these turbines, right, includes the rotor shaft and 2 or 3 blades, right, move vertically. Almost similar to the horizontal axis wind turbine, only component wise. As I told, the axis placement is different. Okay, so then the vertical axis wind turbine is connected to gearbox, similarly like horizontal wind axis turbine, which includes gears. Okay, then the gearbox is directly connected. You can see here the gearbox is directly connected to the electric generator shaft. Okay, and this turbine will revolve once, and the wind blows, and gearbox in this system will enhance the turbine rotations. Okay, I mean it will enhance the speed. I mean it will enhance the rotation. Okay, internally, and it will send these rotation to the generator like mechanical input. Okay, after that the generator will take care. Okay, whatever the available or converted mechanical energy is there, that will be converted into electrical energy with the help of the generator. You can see generator is placed here. This is nothing but gearbox. This is shaft. Okay, and these are the blades. So this is also working principle almost similar to horizontal only, but the placement of the axis as well as the blade shape is little bit different. So this is about the vertical axis wind turbine. Okay, so now we'll discuss about advantages and disadvantages of the horizontal axis wind turbine. Okay, so here you can see I have noted some important 4 points, right? I mean 4 advantages. So the first one is nothing but high power output. Second one is high efficiency. Third one, high reliability. And last one is high operational wind speed. Okay, so first we will pick the high power output. Okay, so normally the horizontal axis wind turbines, right, generally built to have the capacity, higher capacity, that is ranging from 2 to 8 megawatts, okay, depending on the usage of the output, or we can call it as depending on the requirement. Okay, then next one is nothing but higher efficiency. Okay, so and one more important thing is the output with respect to the speed, right? That the capacity almost it varies in the megawatts, that lies between 2.5 to 3 megawatts. Okay, so that much of energy or power it can produce from the available inputs. Okay, so next one is high efficiency. High efficiency means for any type of energy conversion, when you compare with other types also, right, there is always an energy loss. I mean, there is always losses will be there. Okay, so we need to think that how we can improve those losses, right, the net losses, or how we can improve the efficiency by changing the configuration or changing the geometry. So we need to think in that direction. Okay, so currently the horizontal axis wind turbines are having the highest efficiency with a minimum loss. Okay, they can transfer almost 40 to 50% of received wind energy, and that will be converted into the available power. So that's how we are getting higher efficiency. Okay, and third one is high reliability. So reliability means it depends on a number of factors. Okay, so we need to consider some technical things, okay, to make sure it's the high reliability, and those are nothing but the usage, the requirement, and the input, and the velocity of the air, and how much constant velocity, and what kind of equipment we are using, what is the cost of those particular equipment, what is the life of those equipments. So we need to think all the parameters, right? So that is nothing but it's high reliability. Okay, so now last one is high operational wind speed. Okay, so these horizontal axis wind turbine, these are especially meant for the high operational speed only, because they are fixed, they are placed at the higher altitude. When you compare with the ground surface, the vertical distance is more, where we can extract the maximum amount of wind as an input. Okay, so that's why it's meant for only high operational wind speed. So these are the few important advantages which are related to horizontal axis wind turbine. So similarly, we have disadvantages also. Okay, so the first disadvantage is the tall tower and the blades. Okay, and the size of those things varies from, right, so 90 to 150 meters long, and these kind of geometry blades or these kind of equipments, these are very difficult to transport to site. Okay, so that is the one major disadvantage. Then second disadvantage is nothing but it's very difficult to install. Okay, and because these things are huge, as I told, right, lengthwise, if you consider lengthwise, 90, it varies from 90 to 50 meters. So for installation of these kind of equipments, right, the expensive cranes and skilled operators or skilled experienced engineers are required. Okay, that is also some kind of disadvantages. And third disadvantage is nothing but massive tower construction is required to support heavy blades. Okay, so those components and the blades what we are using, even the towers also, right, those are weighing in terms of tons. So that's why the construction and all those things, it's required heavy things. Okay, heavy, and what we are using, right, the blades and the gearbox. Okay, those are little bit costlier. Okay, so then their height makes them obsessively visible across the large areas. Okay, so it's telling is nothing but the whatever the height at that altitude we are fixing those blades, right? So that will spoil the surrounding atmosphere. Okay, it will create the local technical issues, or we can call it as the sometimes it's a local opposition also from the those kind of disturbing, right? Especially in the appearance as well as with respect to the different landscapes. Okay, and these downwind variants, right, almost they suffer from the fatigue and structural failure. I mean, these technical things are related to structural analysis. Those are nothing but fatigue and structural failures. And these things basically depends on the vibration. Okay, vibration. And the main reason and main technical cause for that is nothing but turbulence. Due to turbulence, we're facing fatigue and structural failure with respect to different components in the horizontal axis wind turbine. So these are the few important disadvantages which are related to horizontal axis wind turbine. So in this slide, you can see these are the advantages of a vertical axis wind turbine, and those are nothing but they can produce electricity in any wind direction because the blades are in D shape. They can extract in any direction wind. So that's why they can produce electricity in any wind direction. Similarly, second point, strong supporting tower are not required because these the application of the vertical axis wind turbine are limited or restricted to residential application, right? So that's why the installation, it's almost you can place it or you can install on the roof or at the roof level only. Okay, the height is very minimum height, so that's why the long towers are not required. Then the third point is the low production cost as compared to horizontal axis, because in the horizontal axis what equipments, what devices we are using, right? Like blades, as I told, the blade length it varies from 90 to 150 meters, right? Start from 90 to 150 meters, and the tower and the foundation, right? Those things will be a little bit costlier. Okay, so that's why the production cost is comparatively less in the vertical axis wind turbine, and installation also easy compared to horizontal axis. And whatever the equipments and whatever the setup the we are using, especially for the vertical axis wind turbine, that is easy to transport. Okay, and maintenance also less compared to horizontal axis. Then they can be installed in urban area, especially these vertical axis wind turbine. These kind of turbines are especially meant for urban area only. Okay, and the last one more important point is lower risk for human and birds because blades moves at relatively lower speed. Okay, so that is the most important thing. So that will not impact much to human as being as well as birds. Okay, so these are the advantages. So coming to disadvantages. So first disadvantage of vertical axis wind turbine is as only one blade of wind turbine works at a time, so efficiency is low. Okay, the what number of blade we are using with the different geometry, that also impact on the power generation. So here you can use only one blade. Because of that blade, the efficiency also less. Okay, and second disadvantage is they need the initial push to start. Okay, this action uses fuel of its own produce electricity, right? So to start the setup, right, to run the wind axis turbine, right, initially the energy is required. That is also the disadvantage. And third one is nothing but when compared to horizontal axis wind turbine, right, they are very less efficient with respect to them because so many factors, technical factors, when you compare with the horizontal things, right? Like blades, size, shape, what kind of shape we are using, at what height we are placing, right? All these matters. So based on this thing, we can show it's giving lesser efficiency. And the next disadvantage is because of vibration bearing, right? Where increases as a result the increase of maintenance cost. So here what we are using the shape of blade, and the height, I mean the vertical distance between the blade as well as the bearings, right? So that will increases the, or that will spoil, or that will reduces the component life. So it will again, that is one kind of drawback only. Okay. And the one important disadvantage is these kind of setup, I mean the vertical axis wind turbine, they create noise pollution. Okay. So these are the few important disadvantages which are related to vertical axis wind turbine. Okay. And coming to this slide here, you can see the parameters, different parameters to be considered by selecting the windmill. So these things are more related to the design part only. Okay. So first we need to think in the cost. We need to do cost analysis. Okay, that is the first point. And second point is the area should be open and away from the city, because the horizontal type axis, right? Those things require the open space, open area. Okay, and before selecting that place or that site, we need to do the geographical study as well as meteorological study. Okay. And next parameter is the proposed altitude is to selected by taking average of wind speed, right? So on what altitude you are placing the rotor as well as you are fixing the tower. Okay. So before fixing those things, right, we need to collect the data which is related to the wind speed. At particularly at that height, how much wind we are getting. Okay, that we need to analyze. Then next parameter is minimum wind speed should be available throughout the year. Okay. So it's clear it's very difficult to achieve the constant speed. That thing we know, right? But the basic requirement is the minimum speed or minimum wind is required throughout the year. So that's why most of the wind power plants, right, they are planning to set up in the open area and out of the cities. Okay, at higher altitude, and it should be approached to roadside. Okay, to transport the different components or equipments what we are using for the power plant. Okay. And next one, next parameter is ground surface should be stable and have high soil strength. Okay. So that is very important, because for especially for the horizontal axis turbine power plant, right, the foundation, the tower, and we know that, right, the whatever the component and the equipment we are using, those are in terms of tons. The weighting is in terms of tons. That's why the ground surface should be very much strong. Okay. So these are the few important parameters we need to consider before selecting the windmill. Okay. Then design consideration with respect to the wind turbine. Okay. So these are the few important consideration we need to accept. Okay. First one is it should be small inside and suitable for roof mounting in urban area. This is nothing but the vertical axis wind turbine. Okay. And when you are planning in the urban area, it should not risk, or it should not be issue for the neighborhood. Okay. And the efficiency should be good. Whatever the efficiency, right, we are getting from the setup, that should be good. And it should be free from turbulence. Okay, that is most important, because turbulence is more relates to vibration than the fatigue failure, right? Structural failure will take place. That's why it should be free from turbulence. And last consideration is should be suitable for the mass production for low price. Okay, we need to plan for the mass production, then only we can expect lower cost. Okay. And coming to the performance of the windmills, right? So the performance we are going to define in terms of the coefficient of performance, that is nothing but CP, and it is defined as, or it's the ratio between the power delivered by the rotor to maximum power available in the wind. This is nothing but CP by P max. Okay. And the P max is nothing but half rho U power 3. And here you can see where rho is nothing but the density of air, A is the swept area, and UW is the velocity of the wind. So these are the parameters which we need to consider while calculating the performance of the windmills. Okay. And here you can see these are the different relations which will describe the variation of the power output with respect to the speed. Okay. So on that basis, right, we have different speeds. Okay. with respect to power. Those speeds are nothing but actual speed, rated speed, cut-in speed, and cutout speed. Okay. So regarding this, based on this, the variation power output with respect to speed and the performance, in the next session, we are going to solve some numericals based on these parameters. So here also, we have some important MCQs which are related to this particular session. First question is, how many blades do horizontal wind turbine have? Okay, so he's talking about horizontal wind turbine and the number of blades 2, 3, 4, 5. So as we discussed in the first slide, the construction of the horizontal axis wind turbine, most of the horizontal axis wind turbine we prefer 3 blades only. Okay, so the right answer is 3 blades. I mean the B. Right answer is B. Okay. And question number 2, which of the following are the basic components of the horizontal type wind turbines? Okay. So options are gearbox, controller, accelerometer, and all of the above. So I will repeat, which of the following are the basic component of the horizontal type. He's talking about horizontal type wind axis turbine. So to run the horizontal axis wind turbine, these these 3 components are necessary. So gearbox will vary the speed. Okay, it will convert lower RPM to higher RPM. Controller, it controls several mechanical devices. Accelerometer, which will measure the vibration level, which is related to turbulence. Okay, so the right answer is D. Option D is the right answer. And question number 3, which of the following component is connected to gearbox in horizontal type? Low speed shaft, high speed shaft, controller, and accelerometer. And the right option is A. Similarly, question number 4, a high speed type shaft is horizontal will translate -2. Okay. So option are AC type voltage, rotary motion, linear motion, and none of the above. But the right answer is D. Last question, how many number of blades allow wind turbine to operate at higher speed? More, lesser, zero, single. Okay. So lesser blade, that will be suitable for the higher speed. Okay. These are the frequently asked questions with respect to horizontal axis, vertical axis, advantages and disadvantages of those 2 things, 2 types. Okay. And along with that, some performance parameter like design consideration and performance of the windmills. These are the frequently asked questions. And outcome after this session, right? The student should be able to answer the working principle of horizontal axis along with the vertical axis, and are advantages and disadvantages, and what are the design requirement for the wind turbine, performance of windmills. Okay, and these are the references which I considered for this session. So with this slide, I will wind up session number 2. So next we will meet in session number 3. Thank you.